On the 3rd of March, 1962, the commander of Joint Task Force 8 was directed by the Joint Chiefs of Staff to begin preparations for the fleet operational test of the Polaris weapon system equipped with a nuclear warhead. This test was to be conducted in coordination with the AEC and CNO during the 1962 nuclear test series in the Pacific. Major General Alfred Starbird was commander of Joint Task Force 8. The Polaris test assignment demanded the finest kind of teamwork to achieve the required results within the short preparation time available. Participants, civilian and military, were drawn from widely dispersed sources, some 6,200 men of varied skills and talents. Yet less than 2 months after the JCS orders were received, the Polaris Fleet Ballistic Missile Submarine Ethan Allen, assigned as the launching ship, was being readied for sea at Charleston, South Carolina. She was fully combat loaded with 16 service Polaris missiles. 4 of these had been modified as a peacetime safety feature of the test by the addition of a tracking beacon and a destruct system. However, these changes in no way modified the combat capability of the missiles or of the submarine. In a few days, Ethan Allen passed through the Panama Canal, after which he would make a high-speed submerged transit to the rendezvous point in the Pacific. In the meantime, sailing from Long Beach was the carrier Yorktown with Air Group 55 and Destroyer Division 232, Maddox, Brush, Samuel N. Moore, and Preston. From Port Hueneme came Norton Sound. She was to serve as both the flagship of the Polaris Launch Group and as range safety ship. From the submarine base at Pearl Harbor, Madrigal and Carbonero, assigned to stations in the predicted impact area and fitted with special equipment for burst observation and photography. Operational units of the task force already in the Christmas Island area were also readied for the parts they would play. Ships and task force aircraft maintained constant surveillance of the impact area for safety and security, weather predictions, airborne photography, and other contributing tasks. On Christmas Island itself, 1,200 miles south of Hawaii, 2 degrees above the equator, there was constant and increasing activity. In the Joint Operations Communication Area, planning and preparation had been going on at an urgent pace for weeks. This was an integrated task force effort. On May 2nd, just under 2 months after the orders to go ahead with the test, the Polaris Launch Group, designated Task Group 8.8, rendezvoused at the launch point. This was a spot some 1,300 miles from the nearest land in any direction. At this distance, it was impossible for an accident to cause nuclear danger to any inhabited area. Rear Admiral Mustin, the task group commander, held a series of conferences in the launch area to coordinate final details. This meeting is in the Ethan Allen, submerged and hovering in launch position while other units take station around her. Out of these rehearsals came the final precise timing and coordination required by the special peacetime safety features of this nuclear missile launch. One of the most demanding test features was that of missile tracking for range safety. Tracking was accomplished by an installation specially provided in Norton Sound for this test. Because of the sensitive nature of this equipment, a careful shaking down was required. Search and surveillance operations from Christmas Island to keep the downrange area clear of ships and aircraft intensified as shot time drew near. The 525 miles from Christmas to the impact point assured the safety of the island's inhabitants, but increased the demands made on the aircraft and crews of both the surveillance and sampler squadrons. On 6 May 1962, everything was in readiness. All ships of the launching group were on station. In the launching area were Ethan Allen, Norton Sound, Yorktown, Preston, Maddox, and Brush. Yorktown surveillance aircraft covered the launching area for 350 miles downrange, where the destroyer Samuel N. Moore was stationed. Weather conditions on the day of the test were favorable. Well in advance of the launch, burst observation and sampler units from Christmas Island were ready and in communication with the launching group. Ethan Allen submerged to firing depth. As all hands waited for the task force commander's clearance to fire, the Missile Control Center and Ethan Allen symbolized the tense anticipation of the entire team. And there it goes, Polaris on the way with a nuclear warhead. As the missile rose to its apogee and hurtled on course toward the target point, its contrails were twisted by wind shear in the upper atmosphere. 1,020 miles downrange, Carbonero and Madrigal picked up the countdown as the missile followed its plotted path toward the predicted impact point. Right on the second, the missile detonated at the intended altitude at the target point. Inside Carbonero, a periscope camera was rigged to record the burst and cloud effects. This was the view of the detonation captured by a special topside camera that was mounted on Carbonero's periscope. Now here's another view of the cloud that developed. This is a shot through Carbonero's periscope, which had been pre-aligned on the exact point of impact. "118 miles from surface zero, the Sutherland's bow was aimed directly at the burst point, giving the photographer a perfect exposure of the fireball. Air Force sampler aircraft of Joint Task Force 8 had taken off earlier from Christmas Island to collect samples from the cloud for determination of warhead yield. These samplers were vectored into selected portions of the cloud by a task force civilian scientist flying in another aircraft at the altitude of the cloud. On landing again at Christmas Island, the sampler crews were taken from the planes by waiting RADSAFE officers and were transported immediately to the decontamination center. The particulate and gaseous samples were removed from the aircraft to be flown directly to the laboratories for analysis. The achievement of the sampler squadron was outstanding when it is realized that the aircraft had to be flown 525 miles each way in gathering their vital data. System accuracy was not considered a part of this test because of inadequate knowledge of geodetics in the test area. However, the available data indicated that the Polaris was on target within the established system standards. The operational test of the Polaris weapons system with a nuclear warhead was completely successful, including proof that the warhead had delivered its designed yield in its full service environment. The 1962 test of the nuclear ASROC by Joint Task Force 8 provided an underwater effects test of the nuclear ASROC anti-submarine weapons system. On 12 January 1962, Task Force 8 Commander, Major General Starbird, was directed to include the ASROC in the nuclear test program. He immediately designated the Navy task group of the force to plan and conduct the test under his direction. Less than 3 months later, service ASROC missiles with nuclear warheads were taken aboard the designated firing ship, the destroyer Agerholm, and her backup, the destroyer Richard B. Anderson. and were stowed in their launchers by the ship's regular ASROC crews. Test conditions posed potential radiological dangers. To reduce the seriousness of these hazards, careful consideration was given to RAD-safe measures to protect men, ships, and equipment from possible contamination. Intensive preparations stressed the most advanced safety and protective measures. Following test and training operations off San Diego, the ASROC Task Group, designated Joint Task Group 8.9, sailed on May 6th for final rehearsals and firing. Their rendezvous was at the designated firing point in the Pacific, some 370 miles southwest of San Diego. In the test area, final instrumentation preparations were made for recording data on the ASROC burst effects, both undersea and above it. Many of the devices had been especially designed for this operation. They were set up and monitored by scientists and technicians from many Navy laboratories, as well as from laboratories of the AEC and other civilian agencies. This operation used the skills of men from many sources, men working in units that had been rapidly assembled to meet the demands of the test. On every ship, men bent to their tasks. Here once again was proof that an effective force for a complex mission can be put together quickly and efficiently. After completion of the Polaris test some 1,200 miles to the southwest, Rear Admiral Mustin, the Navy Task Group commander, joined up with Yorktown and its escorting destroyers. This brought the task group to its full operational strength of more than 6,000 men. Admiral Mustin shifted his flag from Yorktown to the Monticello. On 11 May 1962, all was in place and ready. Weather forecast indicated conditions suitable for test. Starting at first light of dawn, the Monticello began the critical task of streaming the 5-mile-long instrumented array. Superb seamanship was the vital factor as the various units of the array moved out across the water. The target raft that would mark surface zero, the platform from which recording devices would be hung to gather information from 2,000 feet below the surface of the sea, and the instrumented coracles. These were only a part of the instrumentation used in recording the ASROC effects, but they provided a particularly important body of information. Leaving the ship, they were strung together like beads on an unsinkable polypropylene line. Also part of the array was the destroyer Bossell, which would be evacuated by her crew for these tests. She was used to measure and demonstrate the effects of the nuclear burst and its radioactive base surge on a representative fleet combatant ship type armed with the ASROC weapon. Well before H hour, the target and instrumented array were streamed and headed into the wind. As shot time neared, Yorktown aircraft maintained surveillance of the test area for both safety and security of the test. They were backed up by appropriately stationed destroyers of the task group. With the array in position, the instrumented ships of the task group moved out to their stations. 4,000 yards from surface zero, the submarine Razorback submerged to periscope depth. Staff members and civilian scientists from various ships shifted to Agerholm, which would fire the ASROC missile. The Monticello's boats evacuated all hands from Bossell and the target platforms. As H hour approached, conditions for observation of the test were excellent. At surface zero, a plume of smoke marked the target position. On the bridge of the firing ship, Captain Siebert checked his assigned position. Ships went to general quarters. All hands were alert. Everything was ready. In the torpedo room of Razorback, special technical gear was readied for launching to gather information on the coming detonation. H minus 30 seconds, the countdown was shifted from time control to a heavily instrumented A3D photo aircraft flying at 20,000 feet on a track to pass directly over the target. This shift of countdown control was to permit the plane to be vertically above the target at the instant of detonation. Aboard Anchor Home, the ASROC launcher lined up on target. The rocket-propelled ASROC headed toward target. In the foreground is the firing ship. At this point, the service fuse completed the firing cycle and the burst exploded skyward. As the burst fell back, the base surge formed, a heavily radioactive cloud of spray and mist which spread to nearly 1 mile in radius. A few seconds later, the detonation bubble collapsed. This caused a new plume to be thrust upward through the primary cloud. The cloud approached Bossell but did not cover her. These views were from the destroyer Preston. Other observers had different views. This is how the burst and shock wave looked from the A3D photo aircraft flying at 20,000 feet directly overhead. The technical photography from this portion has proved to be a particularly valuable source of information. And this is how it looked from another of the technical photography aircraft, an R-5D flying at 10,000 feet, 6.5 miles on a direct line from surface zero. Performance of the 120 cameras used to cover the different technical aspects of this test was considered perfect. As the base surge spread to its full size, it began to drift downwind, a feature which has to be taken into careful account in tactical use of this weapon. Here is another look at the burst from the angle of a low-flying Yorktown helicopter. And this impressive view of the shock wave spreading across the water was seen by the crew of another helicopter. Beneath the sea, the crew of Razorback experienced the effects of the shock wave in a strong shaking that lasted for 45 seconds. The ASROC nuclear effects and weapons system test was an outstanding success from both the technical and the operational point of view. From the recordings gathered by hundreds of devices which function precisely as planned, the project scientist will extract unprecedented amounts of vital data. In the words of one scientist, possibly more data from this one test alone than from the total of all previous underwater tests. And the operating forces of the Navy have gained the information needed for proper and full tactical use of this vital anti-submarine weapons system.